Okay, guys, U3A2, the binomial distribution. This is a little confusing, but it's actually not too difficult, I don't think. So what's going on here is we'll look at an example and we'll work off this example. So I think this is the best way to do it. So there's a 70% chance that an allergy drug will be effective on a person suffering from the allergy symptoms that the drug treats. And we have 10 people and it's effective on 7 people. What's the probability, that it's effective on 7 people? Share your thoughts. So we do something called Bernoulli trials. Okay, so these are independent trials, and there's only 2 outcomes. So that's the key here is you have success and failure, and each trial is separate. So if I have success or failure, that has nothing to do with if you have success or failure. Okay, so they're not dependent. That'll come up next. They're independent. Okay, so you can think about things like flipping coins, rolling dice, that sort of thing. Okay, each time you roll a die, it has the same chance of. It doesn't matter if I rolled a 3 last time or a 4. That doesn't influence my next roll. Same with this. If you have the allergies, if I take a pill, it doesn't matter what happened if you took the pill. Okay. Now, if you come back and go, wait a second, it has 70% chance of success. Isn't that based on experimental probability? That's true. That is true. But once you already have the probability, the trials themselves are independent from each other. Okay, so those are Bernoulli trials. We're going to look at 70% effectiveness, 30% ineffective. So what happens is we just go through it here, and let's say that the first 7 people were to have success. We would have a 70% chance of success, 70%, 70%, 70%, 70%, 70%, 70%, and then the next 3 would be failure. So let me show you what I'm talking about with a tree. So what happens here is we go through a tree and you start drawing branches for each person. So this is person 1, and then you have success and failure. Okay, so it works or doesn't work, and there's a 0.7, a 0.70, 0.3 chance of that happening. So if there's just one person, your tree would just say 70% chance of success. But now if we go to 2 people, you have success and failure, success and failure. So we have all the different combinations, success and success, success and failure, all the way down. And then I'm going to put the 0.7 and the 0.3 on each branch. So if I want to find out what's the probability of having 2 successes, it would be 0.7 times 0.7, and that would just be 0.49, and that would be success. Okay, this is success failure, and then this is failure success. Failure would be 0.3 times 0.3, which is 0.09. And then where it gets complicated here is now I could have success failure or failure success. In both cases, I have one person who's successful and one who failed. Each of these have a 21% chance. So 0.7 times 0.3 is 21. 0.3 times 0.7 is 21. And if I added these together, I would have a 0.42 chance or 42% chance of having 1 success and 1 failure. We can do that with a tree. And you can imagine doing that with a bigger tree. So if I go back, if I take this now, let me go back. If I take this a step further and go another branch, so give me a second here. Let me get rid of this stuff real quick. If I go a step further, this is just driving me nuts. Wait. Okay, if I go next step, I'm going to put this in purple so you can see it. Now we have another branch with success failures. And now we have things where we have 2 successes and 1 failure, 3 successes, no failures, blah, blah, blah. And now how many guys are success and failure? And it gets complicated. And you can imagine if I was to make this a tree with 10 different people, okay, you'd have all these branches, you'd have all these nodes. And then to try to figure out which one of them has 3 successes and 4 failures, or whatever it is that we're looking for, is confusing. In our case, we want 7 successes and 3 failures. And the question is not what the probability of that happening in one single node is, terminal node. So if we follow this through and had success 7 times and 3 failures, we would know that it's 0.7 to the power of 7, right? Because it's 0.7 times 0.7 times 0.7, and 0.3 to the power of 3. Okay, so 7 successes, 3 failures. But the question is, how many times does that happen? And the answer is, or can be found, quite easily, actually, give me a second here, by using combinatorics. So what the formula is when we get to here is, if you want to know the probability of something happening, you use this NCX formula. So this course is great, and there's some great formulas here. So this is the formula right here. So NCX p to the x, 1 minus p n to the x. That's a great formula, but it's going to probably confuse you until I show you what this means. Okay, so we're going to use this example that we're looking at here. So I'm going to go back to SMART real quick. So what that means is the following. If I want to know if there's a 70% chance or a 0.7% chance of success, okay, that means that there has to be a 0.3% chance of failure. Now, how do we get that? Okay, that's 1 minus 0.7. Okay, so we call the rate of success P, and we call this Q. Now, if you don't see Q, what you see instead is, instead of Q, you can just see 1 minus P. Okay, so you have P and Q. Q is found by subtracting P from 1. So if I have 70% chance of success, you have 1 minus 0.7, 0.3% chance of, not percent, 0.30 chance of failure. Okay, so you get that by subtracting that. We call that Q. We can also call it 1 minus P. So earlier we said if I have 7 successes, that 7 goes here because I have 7 successes. And if I have 3 failures, that 3 goes here. Okay, so that's the exponent. But the question was, how many ways can it happen? And the answer is, what you do is, it turns out that it is 10 choose 7. So we know what this is, right? Or you can find out what that is. And what this is this is the number of total trials. This is the number of successes. This is the rate of success. This is the number of successes again, so that goes there. And this is the number of, the rate of failure, and this is the number of failures. So in the equation, they use things like n and x's and p's and all that stuff, but that's how it's set up, okay? So another example, if I want to find out what is the exact probability that half the people would be successful, okay? And actually, let's change this. Let's say I have 50 people, and I want to know what is the probability that exactly half will be successful. What you would do is you put the C here, okay? I have my rate of success is 0.7 or 0.70, okay? And my rate of failure is this, or 1 minus this, same thing, okay? And then I want to find out what is the chance that half of them are going to be successful. You write the total number of people, 25 are successful, and then 25 are not successful. How do you get these numbers here? This 25 goes here, and this is 50 subtract 25 is this 25. So let me do one more example, okay? Let's do a different example. Let's say there's a 99% chance of success and a 0.01% chance of failure then, right? 1 minus 0.99 gets you this. And I want to know, I'm going to do 100 trials of something, and I get it right 99% of the time. And I want to be successful exactly 72 times. I don't know why, but that's what I want to find out. What's the probability of being successful exactly 72 times? The 99 goes here, the 0.01 goes here, 72 goes here, and then this guy, it'd be 100 subtract 72. That is this number right here, which would be 28. Okay, get your calculator out, throw this in a calculator, find out what this is, multiply by this to the power of that, this to the power of that, and it equals, and that's your answer. Okay, so these are called Bernoulli trials or binomial trials. Okay, so what you have here is you have success and failure, independent trials. That's how we do this. Next unit is not going to be independent trials. We'll take a look at that real quick. There's one last thing, and this one you might have kind of figured out on your own. But the only other thing I want to look at here is the expected value. Where are we? So you have your little assignment to do here. Your expected value is going to be right here. Okay, sorry, expected value. So here's a little blurb on expected value. The expected value is just n times p, which makes sense. Okay, so if you want to figure out how many people are going to be successful, okay, so if you have a 70% chance of success, and I said you have 10 people, what is your expected number of people that are going to be successful? Well, it would be 0.7 times 10, which gets you 7. That's expected. So, for example, let's say half the people, go back to that one example here that I had earlier. If half the people are going to be here, half the people, let's make this up here. Let's do another example here where I have 3/4 of the people are successful. So that's my P, okay? And so my P is equal to 0.75. So I do something and 3/4 of the people are successful. And I have 100 people, and I want to know of the 100 people, how many should I expect to be successful? All you do is you take that 100, which is your N, and you multiply it by your P, and then you would get 75. Okay, so pretty straightforward there. That's it for that. And I think that's about it. The only other thing is if you can take a look at the Google Sheets stuff. Okay, so if you look at the Google Sheets stuff, you can see it does kind of get a little bit further into the charts. So take a look at that stuff here and watch this video that goes over how to use Google Sheets. And if you have any questions about this, come and see me. Google Sheets, we're going to be using it more starting now, I guess. I know we touched on it a little bit, but it is going to be a bigger part of our class as we move forward. It is going to be a big part of your final assignment. You're going to have to get used to it. You're not going to be doing this sort of thing on the final assignment, but getting used to what cells are and rows are and all that. I know I've said this before, but that's going to be something that you're going to have to get used to. Okay, so that's it for this unit. Give it a shot. Give me an email if you have any questions. Take care. Bye.